suggestions and directions coming out of the project. And this report that we made is actually both focusing on Sweden and Indonesia, but this today it's going to be on Indonesia. And Harry is going to help me since he's one of the local experts. Okay, and another part of the presentation is going to be the stakeholder perceptions. Can't hear it? That a questionnaire that's been piloted very recently, and it's going to be tried out again on a larger population of health professionals. So we're going to get a sort of a glimpse of how people perceive and basically look at health impacts from climate change, what people know and what people think they know. And that's quite interesting. And in the end, a discussion on both these to see contrast, similarities, and further needs of research and policy and dissemination of knowledge. Okay. So the outline of this talk is an introduction to the field. I'm going to keep it very short because I feel I've been talking about this too much for the same audience. So I'm just going to briefly introduce the background to climate change and health. And then perceptions and way forward. So it's probably going to take about 2.5 hours. I don't really know, but maybe half an hour, 40 minutes or so. And then a discussion to see where we end up. I usually talk too much, so you have to stop me. And if you have questions or you want to discuss something, just wave your hands or scream out loud so we can stop and maybe have a discussion instead, because this is not supposed to be a cathedral lecture. It's a workshop. So when we talk about weather, climate change, and health, we could... There's a color here, right? Is it the B? Here? Yeah. Okay. So we could talk about the risk perception and risk assessment. And I guess this is exactly where we're going to discuss in this session. Risk perception through scientific literature and risk perception through people's knowledge and perceptions and observations. And we're going to discuss risk management less because I think we're not really there yet to do much risk management. We need to know to some extent we are, but to some extent we are not as well. So I'm going to leave this out because I think there is a large need to know more here before we actually can get to the risk management. But in general, that's what we want to do. We want to know more. We perceive a risk. We want to know more about the risk, and we want to manage the risk, adapt to the risk. So this is the long-term goal of Indonesia and other countries and this district to mitigate and to build resilience to the impacts from climate change. Various types of impacts. So just a short introduction to climate. It's as something that affects us all. We're in a specific climate regime right now that's pretty tropical, with lots of rainfall and high temperatures and humidity. In Umeå, as some of you observed in January during the workshop, and some of you observed last week, it's a different type of climate. The climate is measuring weather, basically. So some climates have specific types of weather, and when you put the weather together and measure a mean or a season or a specific pattern of the weather, then you're going to discuss climate. So that's the background to climate. And as we know now, climate is changing. And there's basically more or less a consensus, except for a few researchers. But in the global climate science, there's almost a consensus on that climate change that we see now is due to human activity. And as you know, in the past we've seen climate change as well. We look at, ice cores, etc. Go back for a long time in the history, or other types of observations, and observe other types of climate change, like ice ages and stuff. But what we see now is very, very likely to be generated by our activities. And in the history, if you go back millions of years, or millions, 100,000s of years, and even millions, as soon as there's been a climate change, there's been a large impact on both animal, different species, insects, animals, and humans. So based on that knowledge, we could probably expect us to be affected this time as well. And sometimes it's been catastrophic. So at some point when there's been large climate change in the history, long back in time, the human race has probably been down to only a couple of thousand populations. And so it doesn't, I'm not saying that's going to happen now. I'm just saying that when we've seen these things before, it's been affecting us largely. And I think we could expect that it's going to affect us largely now. The way we need to move ahead with this is to build evidence and knowledge about how it's going to affect us, how we could prevent climate change, and how we could adapt to climate change. So the climate change we see now is from greenhouse gases. And greenhouse gases could be different gases. The most common discussed is carbon dioxide from, for example, car exhaust or fossil burning, basically. But there are other types of greenhouse gases as well. And there is feedback from climate change that cause more climate change, like if a forest would dry out, it would absorb less carbon, and it would be fueling further climate change. There is this complex feedback that we incorporate when we talk about climate change. Okay. If we look at temperature change over the next century, we should remember that from a climatological perspective, 100 years is a very short period. Climatologists usually want to use 500 years, 1,000 years or so when they calculate the balance of the climate system. When we want to use it for other applications in society, for example, we need to have a shorter time frame. So we could bring it down to 100 years, and we could bring it down to 30 years, or 10 years maybe, to some extent. Temperature is changing according to scenarios, and to a different extent in the end of this century, depending on how much emissions we emit, greenhouse gases we emit, basically. If we emit less, it's going to change less, maybe in a global sense, only 3 degrees. It seems a bit positive at the moment. And if we emit more, and business as usual, basically, so we don't really succeed in finding and negotiating on emission reductions, etc., then we're probably going to have a climate change. Temperature is only one of the parameters. And mean temperature on the globe is not very representative of Georgia or Umeå or any other place. It's sort of global measure that we can't really relate to in any sense, basically, except for trying to understand what temperature for the whole globe means. Rainfall changes are also quite affected by climate change, and the intensity and occurrence of events like floodings or droughts, heat waves, various things related to climate, of course. That's a direct effect as well. And then for a longer term, you of course, if you change, if one place goes from one climate regime with climate change to another climate. So you go from subtropical to steppe or something, meaning you have much less rainfall. Of course, it's going to affect everything in the vegetation and in the insect species and humans. What we could grow, how we could find water, how we could behave, because it's quite dramatic change. And sometimes you can see very big changes, even in the climate regimes. So you can see that one place that has a specific climate today, like the temperate, goes to something. Or that a place that's very rainy goes to quite dry. Or the opposite. You go from having a rather dry tropical climate to a very, very wet tropical climate. There's lots of changes you could observe, actually. So just talking about temperature, and which is the base, that's what we usually do when we discuss climate change. It's not really going to represent how things are going to change. I should have incorporated. We did one of these climate regime mapping for the present and the future for the globe in one of the publications. Dave Hondula did last year. And it reveals quite substantial changes in some areas where you go from one very distinct climate regime to another. I'll show it to you someday if you're interested. This looks terrible. So this is the $1 million question. Who understands what this means? This is, yeah. I just explained it. This is from a report by the IPCC, the Intergovernmental Panel on Climate Change. They made this report on extreme events. So this is also to just show that when climate is changing, it's not only climate, it's also more like extreme of events. The frequency and intensity of extreme events, like frequent hot days or heavy rains related to floods. And then you could, instead of measuring temperature, you could measure return values. So you could measure how often something returns today. How often do we have flooding or extreme heavy rain here? Every day, according to me, from Sweden. But for you living here, it's probably some extreme rain probably means something else. So if you observe an event that is to a certain extent extreme, happens every 20th year, how often would it return in the future? That's what they measure here. So everything here, return period, is relative